Right, here we're looking at multiplying and dividing decimals by whole numbers. So when we're looking to carry these out, we do them much the same way that we would do if they were just normal whole numbers. Okay, but the examples we're looking at here involve changing one of those numbers into a decimal part. So one of them should just be a standard number that we're used to, and the other one should be a decimal. Okay, we'll look at when we mix them both up to be a decimal later. Just now, we're keeping one of them as a whole number, one of them as a decimal. So when we're looking to do this, when we are doing it, we're going to set out the same way. So I've got the first example here, 6.2 multiplied by 3. So what we're doing is we're going to put our decimal number on the top. We're going to multiply it by our whole number down the bottom. And after that, we can keep our decimal points in a line, and we can carry out our multiplication as usual. So 3 times 2 is 6, 3 times 6 is 18, times my 8, that's me done. There's nowhere left to carry it. So there, I just get 18.6. Looking at the next one, I get 8.1 multiplied by 32. So again, I'm going to put my decimal number on the top, multiplied by 32 on the bottom. So I'm keeping my decimal point there in the same place, and because this is a 2-digit number I'm multiplying by here with 32, I'm going to have to do a little bit more work this time, but layout still exactly the same. So I'm going to multiply the whole top thing by 2 first of all. So 2 times 1 is 2, and 2 times 8 is 16. So I did my 6, carry 1, right, there it is. So 8.1 times 2 is 16.2. Now I'm going to multiply it by the 3, but remember the 3 here isn't just worth 3, it's in the tens column, so it's actually worth 30. So whenever we're moving across a digit, multiply by the next bit. Because I'm now multiplying by something 10 times bigger, I'm going to stick down my 0 first. And now I can carry on my multiplying like normal. So 3 times 1 is 3, and 3 times 8 is 24. I write down my 4, carry my 2. Once I've done that, here I have essentially worked out 2 lots of it, and there I've worked out 30 lots of it. Okay, but I actually wanted 32 lots, so I need to add these two things together. So add up my columns, 2 plus 0 is 2, 6 plus 3 is 9, 1 plus 4 is 5, and 2 gives me an answer of 259.2. Looking at the third example then, we've got 0.87 multiplied by 4. So a slightly nicer one again, back to just a single digit. So put my decimal point underneath where it comes in my question, and carry on. So 4 times 7 is 28, right, my 8, carry my 2, 4 8s is 32, plus the 2 I've carried is 34, 4, carry my 3, 4 zeros is 0, plus 3 is 3.48. Moving on to the fourth one, I've got 6 multiplied by 3.21. Now again, I've got one whole number and one decimal, but this time they're back to front. And I need to be making sure that I'm writing my decimal on top. So I've got 3.21 multiplied by 6, like that. Put my decimal point underneath in my answer, and I can go from there. So 6 times 1 is 6, 6 2s are 12, write down my 2, carry my 1, 6 3s are 18, plus the 1 I've carried is 19, and that's me running out of sum, so I can just write it down. Moving on to question 5, and we start looking at division. So 5, we've got 37.8 divided by 6, but writing it that way isn't as helpful as it could be, and so this is where we're going to write it out in our kind of traditional division way. 37.8, again depending on when you were at school is going to depend on what you call that. It doesn't really matter what you call it, just get it written out. So working this time from left to right, we want to see how many 6's go into 3. Well, there are no 6's going into 3, carry that over. How many 6's go into 37? Well, 6 6's are 36, that leaves me 1 spare, so 6, carry 1. And again, the benefit of doing this is that my decimal point just carries up. How many 6's go into 18? 3 of them. So the answer to my sum there is 6.3. Moving on to example 6 then. and we can just jump straight into it being in that form. We want to see how many 7s go in to 29.4. Okay, so as we start looking at bigger numbers, we find that this way might not always be the most efficient way, but it certainly has the layout and the procedural method that we need to get the job done here. Okay, and if we kind of carry on, we'll have the debate later about procedural versus conceptual, but until then, I'll follow this one through. So how many 7s go into 2? There are none, taking it over. How many 7s go into 29? 4 of them, with 1 left over. And I've gone past my decimal point, so remember to put it up. How many 7s go into 14? 2 of them. So my answer there is 4.2. Graph of 7. We want to see how many 5s go into 66.5. So how many 5s go into 6? There is 1 of them, with 1 left over. How many 5s go into 16? This time 3 of them, with 1 left over. I've passed my decimal point, remember to put it up. How many 5s go into 15? 3. So my answer, 13.3. And finally, I want to find here how many 6s go into 20.7. So how many 6s go into 2? Well, there aren't any. How many 6s go into 20? Well, it's going to be 3 of them, with 2 left over. I've passed my decimal point, so pop it up. How many 6s go into 27? Well, this isn't an exact one. This is going to leave me with a bit of a remainder. So 6 4s are 24. There's 4. And I've got 3 left over. And so I haven't finished my sum. So what I need to do here is I need to stick another 0 and carry my remainder over. So there's 3 left. How many 6s go into 30? 5. Okay, and so here we found that initially we had 20.7 as the number we were starting with, but in order to finish our calculation we had to add in this extra 0, and you're going to find that as long as you've still got a remainder left after your decimal, you can keep adding in zeros to keep trying to find an answer, and eventually you'll get as far as you need to. Okay, but that's something you need to make sure you're watching out for.